Hey guys, so I'm going to go over one of our free response questions on confidence intervals from the 2011 exam. I'm going to go over from Form B, number 5. So the problem says, during a flu vaccine shortage in the United States, it was believed that 45% of vaccine-eligible people received the flu vaccine. The results of a survey given to a random sample of 2,350 vaccine-eligible people indicated that 978 of those people had received the flu vaccine. So Part A asks us to construct a 99% confidence interval for the proportion of vaccine-eligible people who had received the flu vaccine. And then use your confidence interval to comment on the belief that 45% of the vaccine-eligible people had received the flu vaccine. Okay, so we're going to start with the first thing we would want to decide if we're doing a confidence interval is this going to be means or proportions? And the problem tells us it's proportions. So remember, proportions are always a z. Then from there, we would just have to decide if it's a 1 sample or a 2 sample. Well, if we read up here, there's only 1 sample that they got of these 2,350 people. So I'm going to be doing a 1 sample Z confidence interval. Okay. So now we'll go through the work that I have here. So remember, start with population parameter. So our population is vaccine eligible people. The parameter is proportion who received the flu vaccine. And as I just mentioned, this is a 1 sample Z confidence interval for P. What are our conditions for this confidence interval? Well, our first condition is SRS. Okay, remember that's just really checking that it's random. If we go back to the problem, it tells us it's a random sample. Okay, so that's given. And then approximately normal. So remember, for proportions, the way you check approximately normal is n times P and n times 1 minus P greater than or equal to 10. So since we're doing a confidence interval, we use P hat. So this is my n. How did I get this P hat? I got this P hat by just taking the 978 divided by the 2,350 for the sample. So if you divide those two, that's how you got the decimal I got there. Okay. So n times P hat greater than or equal to 10 and n times 1 minus P hat greater than or equal to 10. So I'm checking approximately normal there. So make sure you write that and that. And then when you're doing proportions, your other condition is always that your population is more than 10 times your sample size. So the population of vaccine-eligible people is more than 10 times 2,350, which seems reasonable. So now I'm going to go ahead and just do the math for the confidence interval. So for the 1 sample confidence interval for proportions, you start with your P hat, okay, which is the same guy from there, and then Z star. Okay, so if you forget how to get Z star is under second vars, and you're going to go to inverse norm, and then it's just 1 minus your confidence divided by 2. So you can even type it into the calculator like that. Just make sure you use parentheses. So it was 99% confident, so I did 1 minus 0.99 divided by 2. And I'm just going to paste that. You don't need to change anything else. And then remember, you can just take the absolute value of that to make it simpler for the calculations. And I'm going to do 3 decimal places. So I'm going to call this 2.576. So that's how I got my Z star. And then your standard deviation is the square root of P hat times 1 minus P hat all over n. Remember, you do not need to memorize any formulas, especially this year, guys. They're going with, since the exam is online, they're going with the assumption that you're going to use your book, you're going to use your notes. Okay, so don't worry about memorizing formulas. Focus instead more on, knowing the procedure and the formula to use for a specific problem. Okay. All right, then I type that in. This is what I get. Okay. Again, if you rounded, there's nothing to say you had to go out this many decimal places. So if you only round it to 3 or 2, remember AP test is forgiving of that. Do not worry about that. And then interpreting it, we are 99% confident that the true proportion of vaccine-eligible people who received the flu shot is between those two values. Again, when you're writing this, just go back to your population and parameter to help you with that. So that's the confidence interval, and then I don't have it written on here, but we're going to just talk about it. So the second part of this says use the confidence interval to comment on the belief that 45% of the vaccine-eligible people had received the flu vaccine. So if I look back at my confidence interval, it's right here. It goes from 0.38998 to 0.44236. So they're talking about 45%. So 45% would be 0.45. That's outside my confidence interval. So since 45% is outside of my confidence interval, it's very unlikely that 45% of vaccine eligible people actually receive the flu vaccine. Okay, so the answer to that second part would be it's unlikely because the 45% is outside of the confidence interval. Okay, so that's part A. Then we're going to move on to part B. So part B says, suppose a similar survey will be given to vaccine eligible people in Canada by Canadian health officials. A 99% confidence interval for the proportion of people who will have received the flu vaccine is to be constructed. What is the smallest sample size that can be used to guarantee the margin of error will be less than or equal to 0.02? So this is a margin of error question. Okay, and the AP test does like to ask about these. Mostly they like to ask about them with proportions, sometimes with means. So we're going to go over that next here. So I just have written up here, again, the confidence interval formula for a one sample. So it's the, like we just use a p hat plus or minus z star square root of p hat 1 minus p hat over n. So all of this right here, whatever comes after the plus or minus, is your margin of error. Okay, so I want this to be less than or equal to 0.02. Now, notice here, this is a different survey. I'm giving this to people in Canada, okay, versus the other one that we did in the US. So you don't necessarily know the p hat here. So I know this has come up a few times in class, but if you don't know the p hat, you use 0.5 as a guess. Okay, and you can see I have that on the work here. So my setup would be 0.02, because that's what I want the margin of error to be, equals, okay, there's my z star. Okay, again, it's the same one we got before, and then times the square root of 0.5 times 0.5 over n. Okay, so you use 0.5 as a guess for p hat if they don't tell you one. So that's my setup, and then you can see I started the work here. So my goal is to get n by itself. So first I divided both sides by 2.576. And then you get some number. So this is where I would suggest just leaving everything in your calculator. So 0.02 divided by 2.576. Okay, so I just kind of wrote out what the decimal is there, but just keep it in your calculator so you don't have to worry about rounding until the end. Okay, and then that would equal then this part here. So I just did 0.5 times 0.5 and made it 0.25. So the square root of 0.25 over n. So my next thing I wanted to do to both sides was get rid of the square root. So I squared both sides. So on my calculator, I can just hit squared, and it'll square the answer. Okay. And notice it's in scientific notation. So just, again, leave it in the calculator. Okay, I kind of wrote it out here. Okay, but you can just leave it in the calculator. And that would equal 0.25 over n. My goal is to get the n by itself. So what I did from there was I multiplied both sides by n to get that n out of the denominator. And that leaves me with this guy. N times this ugly number is equal to 0.25. So then what I would do from there is I would just divide both sides by that ugly number. Okay. So what you can do on your calculator, since you have it in there, is I can just do 0.25 divided by, sorry, there's a glare there, second answer. So answer is under the negative, this guy right here. So if you hit that, that's second answer. So I'm going to do 0.25 divided by that answer. And then again, if you do this, it avoids having to round. So that's what I get, 4,147.36. Okay, and remember, we're talking about a sample of people, can't have part of a person. So remember, you always want to round. Okay, so a sample size of approximately 4,147 is needed. If you rounded up to 4,148, because I think we talked about in class, you could make that argument for always rounding up, that's fine too. But you just need to recognize that you need to round. So it's either 4,147 or 4,148. So, okay guys, that's it for today. I will talk to you soon. Bye.